Good day, students. In this clip, we're going to be going over how to graph transform secant and cosecant functions. All right, so the instructions for the examples are for us to, says for the given functions, find the properties, window, and graph for two periods. So the first example we're going to work on, number one, we're going to work on graphing the function f of x equals 3 secant 2 times x minus pi minus 2. Okay, so we're going to start off by finding out the properties of this function. But in order to graph a secant function, we have to use the related function. Okay, we're going to graph the related function because it tells us where the asymptotes are located. So what is a related function to secant? Well, we're going to use our reciprocal identities. If you remember the reciprocal identities, secant theta is equal to 1 over cosine theta. Okay, and then cosecant theta is equal to 1 over sine theta. So these are the related functions that we're going to be using. So for this problem, we're going to take a detour, and then we're going to look at the related function. Related function, that's what we're going to graph first, and then finish it up later. Okay, so the related function to the given problem that we're looking for is f of x equals 3 cosine 2 times x minus pi. Okay? All right, so for this one, let's find the properties of the related function, since that's what we're graphing. Properties. Now, to find the properties, we need to know our a, b, and h, and k. So to do that with ease, let's go ahead and write down the standard form of a trig function that has been transformed. So that's basically f of x equals a cosine b x minus h plus k. Okay, so with that, I can find my properties. We're going to start out with the new origin. New origin. Our new origin is determined by hk. So hk in this problem, you do the opposite of the number next to the x, that will give you positive pi. And then the other number, negative 2, is your k. You do not have a negative here, so you don't have to change the sign. So that goes h and k. Next thing we want to find are our shifts. The phase shift is h. Okay, h is pi. Since it's positive, that means we're going to be going right in the x-axis direction. Next thing we need is the vertical shift. Vertical shift. The vertical shift is k, and k is negative 2. Along the y-axis, since it's negative, we're going to be going down. Next thing we need is to find is the amplitude. Okay, so how do we find the amplitude of a trig function? Amplitude is determined by computing the absolute value of a. Okay, so we're going to do the absolute value of, we can clearly see that a is 3 here. Absolute value of 3 is 3. Okay, and then we're going to be going up and down. Next thing we need to find is the period. So let's go ahead and find that. How do you find the period? Find the period, you compute 2 pi over b. Okay, b is 2 here, so we're going to compute 2 pi over 2. If you reduce this, 2 pi over 2 is simply pi. So one complete cycle is pi. If we break it into 4 quadrants, we can calibrate by using 4 ticks, equals to 1 complete period, which is pi. That's in the direction of our x-axis. All right, frequency. Frequency is the period per unit time. Frequency is the reciprocal of our period. So if we reciprocate this, 1 over pi is our frequency. Now we have all the properties. Let's go ahead and set up our window so that our graph fits in perfectly with what we want. So our window, we'll start with the new origin at the center. Our new origin is pi and negative 2. We're going to go up and down using the amplitude. And then we're going to go side to side using the period, since we're graphing 2 periods. All right, let's start with our x-axis. This is our x-axis, right? I'm sorry. Let's start with our y-axis. So that's our y-axis right there. So for the y-axis, we're going to be looking at the amplitude. We're going to uh, add 3 and subtract 3. Okay? Minus 2 plus 3 is positive 1. Minus 2 minus 3 is negative 5. Now, how wide, what is the horizontal span of our graph? We're going to do one period to the right and one period to the left. Since our period is pi, we're going to add pi to the right and then subtract pi to the left along the x-axis, okay? So pi plus pi gives us 2 pi, and then pi minus pi is 0. All right, so let's go ahead and sketch our graph. As you can see, we're located in the fourth quadrant. Go to the right pi units and down 2. So we have to compensate for that shift. Let's see. We have 0 to 2 pi, so we have just positive x's. So we're going to shift our y-axis way to the left. Okay. Now, how do we orient our x-axis? You notice that the minimum is very big compared to the maximum, so we have to shift our x-axis higher to compensate for that size. Okay. All right, so let's see. Let's calibrate our x-axis. We're going to go by ones. So we have, let's see what we have here. We're going as high as positive 1. That's 1. And then we're going to go as low as negative 5. 1, 2, 3, 4, 5. Negative 5. Okay. We also need negative 2 to graph our center. All right. How do we calibrate our x-axis? So to calibrate our x-axis, we're going to use what we indicated here. Period 4/6 is equal to pi. So let's go ahead and do that. So we have 1, 2, 3, 4. Now that's pi. And then another 1, 2, 3, 4. Now that's 2 pi. Okay. Now let's graph the center. The center is pi negative 2. So pi negative 2 is right here. Next thing we're going to do is we're going to graph the our new coordinate system. We have the new y axis right there. Shift it to the left a little bit. The new y-axis and our new x-axis. The horizontal line through the new origin. Our maximum is positive 1. And our minimum is negative 5. All right. Okay, now we have our setup. We're going to graph the related function, which is, what is it? It's a cosine curve. So since this is it's just helping us to draw the actual function, we're not going to make it solid. We're just going to make it dotted. All right, so let's put the points in there. So starting from the minimum, well, actually, let's see, it's positive. So we start from the maximum, maximum, and then center, max, center, min, center, max. So there goes the points. And then we're going to go to the left, center, min, center, max. All right. It's kind of hard to see that color. It's not a good color. So let's go ahead and draw our cosine curves. Just dotted. So concave down to the center, concave up to the min, concave up, back to the center, concave down to the max, concave down to the center, concave up to the min, concave up to the center, and concave down to the max. All right. Now, what the cosine function tells us or helps us determine is the asymptotes, the vertical asymptotes of our secant function. Any point where the new cosine function intersects with the central position, you're going to have an asymptote there. So we have an asymptote here, we have an asymptote here, an asymptote here, and an asymptote there. All right. So let's go ahead and draw the asymptotes. So we have one. Make it look nice and long so that you can draw the secant function properly. 1, 2, 3, 4. All right, so there goes your asymptotes. Now, to finish this up, let's draw the actual function. The secant function, we just reflect these u's, this u's up or down. The u's facing up will get reflected downwards, so this gets reflected downwards like this. And then this u facing down is going to get reflected upwards. Let's do that again. It gets reflected upwards, approaches the asymptote, like that. This one facing down gets reflected upwards, and then this u facing down gets reflected downwards. Let's turn it on again. So it just gets really, really close to the asymptotes. So it gets reflected downwards, like that. And then the last one gets reflected upwards. Okay, so that's basically the graph of our secant function. Notice what we did is that we graphed cosine first before graphing the secant function. Okay, so that's that.